Did you know that Azure Defender for servers also include Azure Defender for network, which is a whole set of threat detections for network? That's right. As part of the same plan, you have Azure Defender for server and Azure Defender for network included. In this episode, we're going to go deeply into Azure Defender for network and understand how the analytics are built and the intent and how it works. Stay tuned. We'll be right back. Welcome everyone to Azure Security Center in the Field, episode 29. So thank you very much for the first year of the show. I truly appreciate. If you are new to the show, make sure to visit aka.ms/ASC in the field and subscribe to the Microsoft Security channel to receive notifications when new videos are uploaded. Today we're going to talk about network threat detection, and to go through that, we have a very special guest from our ILDC team in Israel, my friend Koren. Tomer, thank you very much for being here.
Hey Yuri, happy to be here. I'm very excited to participate in your show.
Thank you, Tomer. Let's start first giving you some overview about what you do for Microsoft, the team that you work for.
Yeah, no problem. So I'm working in Microsoft for around 7 years, specifically in the product of Azure Security Center. I work for around 5 years. Since the start of the product, I'm mainly focused on threat detection. I have a lot of experience in several scenarios. What we're talking about is the area threat detection over the network. So I wrote and I implemented various types of threat detection. And I'm going to show you today some of them to talk about.
That's awesome. So we are listening from the source, from someone that is on the team since the beginning. So very exciting to start this new season with this great chat about network threat detection. So the topic is network threat detection. So before I go to more specific questions, can you please give an overview about the solution?
Yeah, no problem. So I prepared some diagram that it would be very helpful to describe the scenario using.
Okay, go ahead.
So basically, what we are doing in our scenario, we collect logs. Like most of security product, we collect logs, and based on the logs, we are doing a lot of analytics. Some of them are rule-based, some of them are machine learning-based. Now, the logs that we are currently using, there are two main logs that we are using. One of the logs that is very popular to use is login events from the operation system. We look at the operation system and we know whenever some entity tries to log in into the machine, we see if the login was successful or if it was failing. And based on this pattern and a lot of logic, we can determine if there is some kind of brute force or other kind of attacks. Now, this is very nice and a very accurate solution, but the problem is that it's based on the login from an agent. So any customer of Azure, in order to use this kind of flow, need to install the agent. Now imagine that there is some VM that is compromised for some reason. The attacker can shut off the login or temper them. So in some scenario, this is not very accurate because someone can temper them. So in order for us to get a broad view of the scenario and not be dependent on specific agent, we also using logs from the router. Now, as you know, Azure is using a lot of edge routers to route its traffic from Azure from Azure to the internet and from the internet to Azure. And those edge routers have some property to emit logs from the router using a protocol that is called IPFix. IPFix is a protocol that enables the router to report some communication patterns that it see along its operation and send them to some central place. We collect those logs from the edge routers and we process them, and this information allows us to see the all traffic of Azure. It's not a specific VM, it's not a group of VMs, it's the all Azure traffic. And using this information, we have the cloud smartness, and we have the cloud view, and this allows us to do a lot of great things. So using this signal, the IPFix signal, we also have a set of analytics, and eventually all the analytics are based on those two events. So this is in general the overall view of what are the families and how the raw data is implemented. Now let's talk about the specific analytics. So what kind of analytics are we implemented? What is actually a network threat detection? So basically, network threat detection is the network. As you know, the internet is it's a wild west. There is a lot of traffic. Everyone can join the internet, and it's not a really safe place. So it's not very hard to see attacks that are it's some kind of brute force. Mm-hmm. There's a lot of scanners in the internet, and attackers can sometimes go and try randomly select VMs and try to enter and see if there is a weak password. So one of the analytics that we have is some analytics to determine RDP or SSH, brute force attacks. So this is one kind of attacks that we know to discover based on the login events and based on the IPFix events. In addition, we have another set of analytics that determine different protocols that are also exploitable by attackers. Some of them can be SQL server. Sometimes also attackers try to infiltrate those systems. We have also some kind of generic brute force, something that know to identify a protocol that is it looks like there is something different in this protocol. So we also know how to identify this behavior. And this is a type of incoming attacks. Incoming attacks is something that comes from the internet to the specific resource.
Awesome.
And we also have something that is called outgoing attacks, which is attacks that coming from the infrastructure of Azure, from the specific VM to the internet. And we also have some kind of analytics that discover this field. So in general, I can also elaborate more. It's depend.
No, I think it was a great overview. Explains very well how things work and makes a lot of sense. Now, is this only for Azure VMs that are being monitored for Security Center, or this is also applies if we are looking at scenarios where we have our on-prem machine or even a machine in a different cloud provider?
Well, it's a good question. So basically, as you know, the IPFix log is collected using the Azure core routers. So in case that we are using different cloud providers or different on-prem environment, those routers are not reporting logs to us, so we don't have this feed. But what we do have, we can collect logins events using Azure Arc. We have if a customer wants to be protected by our solution, he can install the agent either on his on-prem machines or either on the cloud, on the VMs on other cloud provider, and he will be protected by the login events. He will not be covered by the analytics of the IPFix, but he will be covered from the login events, which also cover a lot of scenarios.
Yeah, that's a good point. Now, when you explain about IPX, IPFix, and everything, yes. What type of data are you collecting to analyze? The header? I mean, what type? The entire package?
Yeah. Okay. So IPFix basically contains the overhead of the communication. It's contain the source, the dest. So we generally know who talks with whom. Like we have the source IP, we have the destination IPs, we have the number of packets. So using this topological information, we are able to view all the general picture of who is talking with whom and with what kind of, what is the amount of connection. So this is give us a good, decent understanding of what's going on the network. So these logs enable us to infer about what is going on and then act accordingly.
Mm-hmm. Yeah, and based on your experience, since you've been working with the product and with this area for so many years, what are the most common type of alerts that are generated by this threat detection, and what could be done, right, to mitigate it?
Yeah, so basically, as you know, in the internet there are a lot of open source tools the popular one of them, there is the Kali Linux that contains a lot of attacking tools. One of them is the Hydra tool, which enable you to do some kind of RDP brute force or SSH brute force attacks. So those ones are, I think, are the most common. And basically for Hydra, what you need to do is you just need to go to the, look how simple is it. You just go to the GitHub, you write a Hydra, and then you have a full information of what you need to do, what kind of commands. And this is what basically like very common attacks that people just try it. Like they go, this is like a sample, a screenshot of a tool of Hydra. That's what is going on. It's just you mentioned some kind of IP, and then it try to run over a bank of passwords and try to enter the machine. So this is a very, very common attack on the internet, either for RDP and SSH.
Interesting.
So,
and what about because there is also a lot of noise, right? So in order for you to have more certainty that it is a true positive, do you do any type of verification or suppression to avoid noise?
yeah, so to avoid noise, you can tackle it in several areas. One of them, when you train a model or you define a set of analytics, you make sure that the threshold is some kind to balance the threshold, and you let the model, if it's anomaly based, you let the model learn what is a normal behavior and what is an benign, like what is an attack. So based on this information, you can calibrate the model. But on the other end, the threshold and everything, what we are also doing, we use this solution inside Microsoft. So whenever we notified about brute force inside Microsoft or inside some of our customers, we approach them, and then we can verify based on feedback. We know whether we should do some modification to handle this noise. But yeah, I agree. There are many attacks of these types, and sometimes you need to update the threshold just to make sure the customer is not being notified too much.
Yeah. So
And
just to make sure that the audience understands, all the adjustments is done on the back end. In other words, there is nothing really to be configured in Azure Security Center, correct?
Yeah, sure. This is something that we are doing in the backend side on the analytics themselves. We are keep monitoring the performance on those analytics, and whenever there is some kind of concern that we may be notify customer too much or something, then we take care of it and we calibrate the thresholds. And sometimes, you need to update the model. So it's very depend which protocol and which kind of attacks, because it's very different between protocols.
Yep.
But yeah, this is the advantage of us taking care for it for our customers.
Absolutely. And do you have a demo to show us?
Yeah. So basically, what I did, I tried to simulate an attacks. I did it like before we were meeting, and eventually, what I did, I tried with Hydra. I tried to attack some VM in my hand, and eventually, when I finished the attack. Eventually, after a while, in Azure Security Center, I started to see security alerts that explain to me that someone is trying to access my VM. So, as you can see, this blade is the blade of security alerts in Azure Defender for Azure Security Center in the category of Azure Defender. And as you can see, this specific attacks was coming from the network. So the name of it was the alert type is suspicious incoming RDP network activity, because we are not this analytics come from the IP fix. So we assume based on the model this is something that looks suspicious. So this is why we said it's suspicious. This is the name of the resource. This is when the first time that was happening, the attack, and this is a description. When in the description it says that my machine was the algorithm detects some kind of anomalous communication on RDP port from on my machine. From this is the IP of the attacker, and eventually the stage, you can see here that the stage is a pre-attack. So usually attacker, in order for them to start some kind of attack, usually they sniff and they look for the target. So this is the stage. And based on this information, I am able to infer that something happened, and then I can try to do some stuff. I need to do some action whenever I'm taking this kind of alerts. I need to do some kind of steps. So in this specific alert, there are several recommendations that advise me what to do. Some of them include to block the attacker from a network security group. Eventually, this kind of attacks can be, you can stop it if you are preventing it using some good practices. One of the good practices is, of course, to close the VM, specific VM from the internet. This is the best scenario. When you close the door, nobody can enter. Now, if you still need to access the machine, you cannot just lock the door. You need to let people in and out sometimes. So there is the options of using network security groups. I will show it here just a second. A network security group. So this is this is a VM, an example VM, and this VM, as inside the networking layer, there is something that called network security group. Network security group is basically a set of rules that enable you to control who is enter to the network and who is going out. So in this case, in order to enable the attacks, I add some rule that allow all of the internet to come and communicate with my RDP port. Now, in order for me just to mitigate an attack, first of all, I can delete this rule, but then nobody can enter. But the other thing that I can do is limit the source. Like instead of doing determine that anyone can go into the IP, I can either say that I want to define a specific IP, a group of IPs, and this is a very good practice to limit the number of IPs that can enter to your machines. So this is like a second mitigation. Like the first one was to delete the endpoint that goes to the internet. The second is to limit the audience of IP, the scope of IPs that can connect to the machine. And there is a third solution. The third solution is something that is called just-in-time communication. This is a feature of Azure Security Center. So if you go to in the VM, you go to the security tab, you can see the just-in-time VM access. Just-in-time is basically a feature that enables you to open the gate for a limited time, and then you can do your things, connect to the machine, do whatever you want, and eventually after some kind of time, the door will lock again. And this is also a very good practice to use. So for customer, if they want to do to join to this solution, they just need to define in my scenario, target is the VM. Everything is very easy. Like even to configure the NSG is easy. Also the JIT is from the portal. And then when you want to do some JIT, you just said that I want to do it on the RDP port, and that's it. And then you save.
That's just one observation that the just-in-time VM access is a feature of Azure Defender, right? So if customers, they need to have the Azure Defender on in order to have the JIT capability.
Yeah, also to getting the network alert. If I didn't mention before, Azure Security Center, the Advanced Threat Protection is a feature of Azure Defender for server.
Right.
So whenever you are hopped in to this service, you are getting the alerts, and you're getting also the ability to use this feature of just-in-time.
Yep.
So you can use it, or you can just use the summit. It's up to you to decide. But really, the best way to be strong against those kind of attacks is just to have a good practices, security practices, and it reduces most of the attacks that are coming from the network.
I really like the fact that you emphasize that in order to have the network threat detection, you need to have Azure Defender for Server. A lot of people, they don't realize that when you enable Azure Defender for Server, you also get network threat detection. So make sure that you understand that, and I'm going to put the link here for the documentation that explains the available alerts that you may receive coming from the network threat detection that we have. All right, Tomer, do you have any final consideration, thoughts that you want to share with our audience?
For me, I recommend that whenever you deploy a new resource or service to Azure, I recommend to read the blogs or to read on the website in Azure. There's a lot of good stuff to get you familiar with all the best practices. And this can save you a lot. This can save you a lot of problems
Absolutely.
in the future.
Yeah. Great point. Great point. Read the documentation. Again, link below. And that's it. That's a wrap for episode 29. Thanks again for your audience. Make sure to subscribe, aka.ms/ASC in the field. This is season 2, starting with this episode, and we have a lot of great guests lined up for this year. So stay tuned. See you next time.